mesomeric effect or resonance effect. So what is mesomeric effect and same its applications. See here, this mesomeric effect is observed in conjugated system. Okay, it is only possible in conjugated system. What is the meaning of conjugated system? In last class we have studied there is a pi electron, pi bonds are conjugation, pi bond lone pair conjugation, pi bond negative, pi bond positive, pi bond odd electrons are conjugation. Therefore, let us take, it is a pi bond, let me take here is NH2. Okay, it is a pi bond, sigma bond, lone pair are in conjugation. So therefore, now it is observed in the only conjugated system, that is, so here conjugation, in conjugated system, if the pi bond and lone pair are in conjugation, this lone pair involved in resonance, this pi bond shifted here, then what do you get? CH to become CH2 minus CH double bond, NH2 become NH2 plus. It means, tell me, in first molecule, is there any polarity in the first molecule? The meaning of polarity is there should be a positive and negative charge. It may be partial, it may be complete. So is there any charge on this molecule? There is no charge. It means first molecule do not have any polarity, but second molecule has polarity. This polarity is produced due to what? Displacement, right? Nothing but complete transfer. So displacement of what? Pi bond as well as lone pair. Then how do you define this is mesomeric effect. Then how do you define mesomeric effect? The polarity produced in the molecule due to interaction between pi bond and lone pair in a conjugated system is called mesomeric effect, right? So due to mesomeric effect, polarity will be produced. The polarity produced in the molecule due to what? Interaction between pi bond and lone pair. Okay, that should be in a only conjugated system. Therefore, mesomeric effect is only possible in where? Conjugated system, but not in non-conjugated system. So therefore, so what is the definition of mesomeric effect? Polarity is produced in the molecule. Polarity produced in the molecule due to interaction between pi bond and lone pair in conjugated system called mesomeric effect. So therefore, polarity produced in the molecule due to the interaction between pi bond and lone pair in conjugated system. What is the meaning of conjugated system? In last class and we have studied in detail about conjugated system, right? In the meaning of conjugated system is pi bond and lone pair, or pi bond should be in alternate positions. Okay, so it is a conjugated, this is what? Mesomeric effect. Then what are the characteristics of mesomeric effect? 1, tell me, is it temporary effect or permanent effect? So we have studied only one effect is a temporary, that is electromeric effect. Only electromeric effect is, sorry, temporary effect, yeah, temporary effect, remaining all are permanent effect. So this is a permanent effect because the lone pair present in the molecule, pi bond present in the molecule. As long as lone pair, as long as pi bond is present, this effect is always possible, right? There is no attacking reagent is attacking here. So therefore it is a permanent effect. 2, now in this effect there is a complete transfer or partial transfer of electron, or complete displacement or partial displacement. There is a complete displacement of electron takes place. That's what we have written, complete negative, complete positive, right? So there is a complete transfer of pi electron takes place. Okay, next, third one, whether it is observed in saturated molecule or unsaturated molecule. It must be observed in unsaturated molecule having conjugation. There must be a conjugation. Therefore, it is observed in unsaturated, conjugated systems only. Next, fourth one. Now, this mesomeric effect is independent of distance. It means it does not depend on distance. For example, you say it is 1, 2, 3. There are 3 atoms. No. For example, if I write CH2 double bond CH, double bond CH, NH2. Tell me what is the difference between this molecule and that molecule? 1, 2, 3. There are 3 atoms. 1, 2, 3, 4, 5 atoms. Then what is the difference between mesomeric effect? There is no difference. Both will have same mesomeric effect, because NH2 group is same. Here NH2 group will be same. Right? There is a conjugation here also. Conjugation. It means mesomeric effect is independent of distance, but it depends on position. So remember, mesomeric effect operate from ortho position, para position. It do not operate from meta position. That means it depends on what? Position, but not distance. Can you tell me which is depends on distance? Inductive effect. So only inductive effect is depends on distance, but inductive effect does not depends on position. Inductive effect can operate from ortho, meta, para. It operates from all the positions, but not this. Therefore, fourth characteristic is it does not depends on distance, but depends on what? Position. That is, it operates from ortho, para positions. So it operates from ortho and para position, but not from meta position. So therefore, mesomeric effect does not operate from the meta position. Why does not? We will study later in application. It operates from only ortho and para positions. Okay. Then what about inductive effect? So that also write one point right under note. Inductive effect operate from or inductive effect depends on, it depends on distance, but not on position. That is, it operate from where? Ortho, para and meta positions. So it operates from all 3 positions: ortho, para and meta positions. Okay. So these are the characteristics of mesomeric effect. Next is types of mesomeric effect. Types of mesomeric effect. Okay, and tell me, mesomeric effect classified into 2 types as like inductive effect, plus M minus. So it is of 2 types, plus M effect, minus M effect. Okay, and tell me, plus M effect exactly similar to plus I effect. Do you remember what is plus I effect? The displacement of sigma electron away from the substituent. No, away from substituent plus I, towards substituent is minus I. Okay, then plus m is same. Here is displacement of pi electron, there sigma, here is pi. Displacement of pi electron away from the substituent in a conjugated system is a plus m. Then what is the minus m? Displacement of pi electron, there is what? Displacement of sigma electron. Here displacement of pi electron towards the substituent is a minus m, that is minus I, here is minus m, but condition is in conjugated system. So therefore tell me, what is a plus m effect? Displacement of pi electrons away from substituent in conjugated system. Displacement of pi electrons away from the substituent in conjugated system called plus m effect, and groups are called what? Plus m groups. Okay, so groups are called plus m groups. Now let us see example. So this example can be taken as a plus m. For example, CH2 double bond CH NH2. Nitrogen has one lone pair. Come on, tell me. Lone pair sigma bond pi bond conjugation. Therefore, lone pair involved resonance. This pi bond shifted here. Then what is the resonance structure? CH2 negative, CH double bond NH2, it is positive. Now tell me, here this NH2 group is a substituent. Okay, it is a substituent. Then displacement of electron takes place towards or away? It is from away from the substituent. Okay, next. So therefore, it is a substituent. The displacement of electron takes place away from the substituent. It means electron releasing, electron withdrawing. That means plus m groups are all electron. So therefore, plus m groups are electron releasing groups. Next example. So what are the example for a plus m groups and how to identify? In previous class also we have studied the groups which are having one or more lone pair, right? The groups which are having one or more lone pair on central atom can be act as a plus m groups, right? Therefore, groups having one or more lone pair electrons on central atom can act as plus m groups. So can you tell me example? Like amine, NH2 one lone pair, next comma NHR, comma NRR. Tell me. H2, yes, that is HS. HS no, bond will be there, the two lone pair, or SR, comma OH, comma O methyl or OR, or any alkoxy group, oxygen has lone pair. Even important, halogen atoms having three lone pairs, which is also plus m group. Yes or no? We'll study. So halogen is a plus m group here, but it also acts as minus effect. So therefore here halogen and alkoxy. So these groups are, they exhibit plus M and even minus I, these two effects. Okay, then next is take the order of plus M effect. Order of plus M effect. Important. O minus has highest minus M effect, NH minus, NHR minus, only N, NR minus, OH, OR, amide, ester, phenox, pH, phenyl, chloride, fluoride, chloride, bromide, etc. Last one is NO, NC. 1, 2, 3 is neutral. Okay, so these are the important minus M plus M groups. Okay, next is minus M effect. Order, you have to memorize it, you have to remember it. Minus M effect. Tell me, it's quite opposite to plus M effect. So therefore, tell me, in plus M effect, there is a displacement of pi electron takes place away from the substituent in conjugated system. Then what is a minus M? Displacement of pi electron takes place towards the substituent in a conjugated system. So therefore, displacement of pi electron takes place towards substituent in conjugated system. Right. So displacement of pi electron takes place towards the substituent in a conjugated system. It is called minus M effect. Okay. Then example. Let us take CH2 double bond CH. I'll take here aldehyde group. Tell me. Now here this aldehyde group is a substituent. Their amine group, here aldehyde group. Now this is substituent. In this substituent there is a carbon oxygen double bond. Among carbon oxygen, whose En is more? Oxygen. Therefore pi electron shifted on oxygen. At the same time this pi bond shifted here. So therefore then CH2 gets CH2 positive because it losing its pi bond. then CH will be same, then it become double bond, O become O minus and H. So therefore, there is a displacement of pi electron takes place towards substituent in conjugated system. And this group is called what? This group is called? Yes. So therefore plus M group is a electron withdrawing group. Yeah, minus M. Minus M group is electron withdrawing group. Then now how to identify minus M group? So this kind of questions are very common. Which is a plus I effect, which is a plus I group, which is minus I group, which is plus M group, which is minus M group. Okay, even tomorrow exam also there are questions given like this. How to identify plus M, plus I, minus M, plus I, minus I. And tell me, how to identify the minus M group? Right, this is a minus M, right? So the groups which are having multiple bond between carbon and more electronegative element, like carbon oxygen, carbon nitrogen, carbon sulfur. Okay, therefore the groups in which are having multiple bond between carbon and more electronegative element can act as a minus M. So therefore the groups which are having carbon multiple bond with more electronegative element. The groups which are having carbon multiple bond with more electronegative element can act as minus M groups. Like example, tell me. So which group having carbon multiple bond with more electronegative element? Like aldehyde, comma, ketone, comma, cyanide, comma, nitro, yes or no? Even comma, carboxylic acid, comma, ester, comma, amide, comma, acid halide. Wherever C double bond is present, that is minus M group. Next, order of minus M effect. Right. So among minus M groups, which is the strongest minus M group? So remember, and tell me, NO2. Yes, this was the previous question. NO2 is the strongest minus M group. Next is sulfonic group. Next, sulfonic group. Next is cyanide group. Next is aldehyde group. Next is ketone acid halide. Next is anhydride, comma. Next is amide ester. So this is the order of minus M effect. Okay, I'll write some example. You try to identify which effect is present. Okay, example 1, CH2 double bond CHCl, CH2 double bond CH double bond CH NH2, CH3O CH tell me. So 1 2 3 4 5 6 7 8 9 10. And tell me first one. It is a plus M effect, right? This is a substituent. It is plus M effect. Next, plus M effect because there is a lone pair, no? Next, it is also plus M. Now this is substituent, plus M effect. Next, it is also plus M because lone pair involved in benzene ring, no? Then this pi electron shifted here, right? It is also plus M. Next, it is minus M. This pi shifted on oxygen, this pi bond comes outside, okay, therefore it is a minus M. Next is minus M. Next is plus M. Next is plus M only, no? Yes or no? Next is, it is plus M. Next is, see, lone pair is there, no? I am not asking inductive effect. Don't confuse. I'll tell you when two or more effect comes, I'll tell you there. Tell me here plus M or minus M. It is plus M because lone pair, right? The groups which are having one or more lone pair, they can exhibit plus M effect. Next, applications of mesomeric effect. Applications of mesomeric effect. Tell me. First one, stability of carbocation, carbanion. You have been studying in every electronic effect. Stability of carbocation and carbanion to relative acidic strength of aromatic carboxylic acid, right? In plus effect we have studied aliphatic carboxylic acid. Here is aromatic carboxylic acids. Relative acidic strength of aromatic carboxylic acid. 3. Relative acidic strength of In plus I effect we have studied alcohol. Which is the aromatic alcohol? Phenol. So relative acidic strength of aromatic alcohol nothing but phenol. Fourth one, there we have studied relative acidic strength of basic strength of amines. Okay, here we study relative basic strength of aromatic amines, right? Therefore plus M effect minus M effect is observed only in conjugation, right? Conjugation is possible in aromaticity, right? Aromatic compounds. Therefore fourth one is relative basic strength of aromatic amines. So what are the aromatic amines? Aniline, right? So general example is aniline. Okay, so what are the aromatic carboxylic acid? Benzoic acid. Okay, let's see one by one. First one, stability of carbocation and carbanion. So which carbocation, which carbanion? That is in conjugation. No, they must have conjugation. Tell me, which carbocation and carbanion has conjugation? There are only two examples, allylic and benzylic. Let's see first allylic carbocation. Come on, tell me. This is allylic carbocation and benzylic carbocation. So allylic carbocation can form how many resonance structures? Two, no? The number of resonance structures equal to what? Number of conjugate positions. There are 1, 2 conjugate positions, 2 RS. Here how many? 4 RS, 4 conjugate positions, right? Similarly, it is carbocation. In case of carbanion, let us take allylic carbanion and benzylic carbanion. So allylic carbanion can form how many RS? Same 2 RS. Here 4 RS. So therefore, now if you compare allylic and benzylic carbocation, which is most stable? Obviously benzylic carbocation most stable compared to allylic carbocation. Then here benzylic carbanion is most stable compared to allylic carbanions. Okay. Then what is the stability of allylic carbocation, benzylic allylic carbanion? There is no comparison. It is a carbocation, is a carbanion, no. How do you compare carbocation and carbanion? You can compare carbocations only. You can compare only carbanions only. Don't compare stability of this and this. There is no stability comparison. Okay. That is a carbocation, that is carbanion. Both the structures are different, its stability different, everything different. Okay, fine. Now next important is, let us see stability of carbocation directly proportional to plus M effect. Yes or no? Inversely proportional to minus M effect. Next, what about stability of carbanion? It is directly proportional to minus M effect, but inversely proportional to plus M effect. We will see the example. Only examples are important. You need to identify the answers. Okay. Now let us take benzylic carbocation. It is benzylic carbocation. Next, benzylic carbocation, or right, I'll write here, benzylic carbocation, and benzylic carbocation having methyl group ortho position, and benzylic carbocation having methyl group meta position, and benzylic carbocation having methyl group para position. So tell me, what is the order of stability? Now tell me first, all are benzylic carbocation, right? Then what is the difference? Yeah, there is a methyl group, right? The position of the methyl group. we need to identify whether methyl group can exhibit which effect. One, we know that plus M effect. So all alkyl group there is a plus, plus I effect, plus I effect. Okay, inductive effect. Alkyl group no. So therefore ortho position plus I, meta position plus I, para position also plus I, because plus I effect or inductive effect does not depends on position, it depends on its distance. Among 1, 2, 3, where the plus effect is more? Ortho, because inductive effect become less, means decreases when it is goes to 4th carbon. That is we have studied. Therefore in all the 3 cases plus I effect will be there. Next tell me, what other else? What else other effect? There is a hyperconjugation. Remember, when benzene ring is attached to alkyl group, there is a hyperconjugation, because this carbon sp2 carbon attached to sp3 carbon having at least one alpha hydrogen, there is a hyperconjugation. Today we will start that topic. Today not possible, tomorrow. Okay, therefore hyperconjugation is possible. Then remember, hyperconjugation operate from only ortho and para, it does not operate from meta position. So that also one note you can remember, hyperconjugation operates from ortho and para positions only, not meta position. Okay, fine. So therefore hyperconjugation here is what? Here no hyperconjugation. Why? This is meta, here is hyperconjugation will be there. Okay, now tell me, at ortho position methyl releases electron because of 2 effect, inductive effect, plus I effect, hyperconjugation. Meta position methyl group release electron because of only plus I effect. In para position methyl group release electron because of plus I and hyperconjugation. Now question is, it is carbocation. Carbocation stability increases when the electron releasing group present. That means carbocation become more stable when there is what? Electron releasing. Where the more electron releasing, more stable. Tell me, which is more electron releasing? 1, 2, 3, 4. Tell me, which is more electron releasing? Second as well as 4. In second as well as 4 cases, electron releasing effect is because of 2 effects, plus I hyperconjugation, plus I hyperconjugation. Therefore 2 and 4 are more stable compared to remaining all. Now I want among 2 and 4 which is more stable. Again, now where the electron releasing is more? Electron releasing more in case of 2, because hyperconjugation will be same here. See, hyperconjugation does not depends on distance. Whatever may be the distance, hyperconjugation will be same. Okay, like mesomeric effect. But which is depends on position? Sorry, distance, inductive effect. So here inductive effect is very close to this. Here plus I effect is away, no? Therefore where the electron releasing is more? Second. Therefore second is more stable compared to 4. And next 1 and 3. In 1 there is no electron releasing, of course no electron withdrawing, but there is one electron releasing due to only plus I. That's what? That is 3, then 1. So this is the order of stability of carbocation when there is electron releasing group is there. If there is electron withdrawing group, carbocation. Next let us take NO2, electron withdrawing group. Next meta position NO2, para position NO2. Tell me, now NO2 group is electron withdrawing group. So first of all you need to identify NO2 can exhibit which effects? 1, minus I, because when more electronegative element present on carbon chain, it is minus I is will be there. Along with minus I, there is minus M. It is minus M group. Next here, there is a minus I but no minus M. Minus M not possible because mesomeric effect does not operate from meta position. Next, minus I will be there, minus M will be there. Tell me, what is the order of stability? So we know that all the three groups are what? Electron withdrawing groups. Electron withdrawing group decreases the stability of carbocation. Therefore, which is more stable? 1, 2, 3, 4. 1 is more stable because there is no electron releasing, no withdrawing. Okay, next, among 3, where the electron releasing is maximum? In 2, electron withdrawing is maximum. Second, no. Electron withdrawing is maximum, it is minimum stable. Stability is minimum. Where the electron withdrawing is minimum? 3. Because only one effect, no. Only minus I effect. Minus I, minus M. Minus I, minus M. So due to 2 effects, they withdraw electron very strongly. Therefore, electron withdrawing is minimum in case of 3. Therefore, 3 is most stable. Next, among 2 and 4, where the electron releasing is maximum? Minus M will be same. Minus M illidre same barutte, illi same barutte. Minus M does not depends on distance. Estrana durerli. Minus M will be same. But which is depends on distance? Minus I. Inductive effect depends on distance. Dura adre kami agutte. Therefore, now, so which is more? Here minus I is more. Here minus I is less. Therefore, which is more stable? Fourth one more stable than second. It is the stability of carbocation, benzyl carbocation. Let's see carbanion. Okay, so let us take one more question. Benzylic carbanion, CH2 minus CH2 minus methyl group, CH2 minus meta position methyl group, para position methyl group. So let us take, this is A, B, C, D. What is the order of stability? Stability of carbanion. So here the carbanion stability is directly proportional to electron withdrawing group, inversely proportional to electron releasing group. Therefore, here, yeah, plus M, this is which group? Plus I group and hyperconjugation. This is plus I group, no hyperconjugation. Here plus I group, hyperconjugation. It means all the plus I and hyperconjugation both are electron releasing groups, electron releasing effects. Therefore, when electron releases, the stability of anion is decreases, right? Therefore, anion become more stable if there is electron withdrawing group. If not electron withdrawing group, there should not be a group. Therefore, tell me now, which is more stable? A is more stable because there is no electron releasing, no, of course, withdrawing. Then, now where the electron releasing is less? In C, because in C there is only one effect, that is plus I. Okay, so therefore electron releasing effect is minimum. Next, where? D. Why not B? Because here plus I is more. Hyperconjugation will be same here and here. Here plus I will be more. means electron releasing because of plus I is more, right? Here plus I is less, distance is more. That's what electron releasing is less compared to B is D is less. So then D, next is B. Okay, next one more. Tell me. So what is the order of stability? So the stability of carbanion increases when there is electron withdrawing group. So NO2 electron withdrawing group, it is due to minus I minus M. NO2 only minus I. Para position minus I as well as minus M. So which is most stable? B is most stable, then D is most stable, then C, then A. Therefore A, B, C, D. So this is how stability of carbocation carbanion is changes. Next, second application is relative acidic strength of carboxylic acids. Okay, so relative acidic strength of aromatic carboxylic acids. Okay, so do you remember in last class we have studied among aliphatic and aromatic carboxylic acid which are more acidic? Tell me. Aromatic carboxylic acids are more acidic. This is because where in aliphatic carboxylic acid there is a plus I group and in aromatic carboxylic acid there is a minus I group. So this phenyl ring is a minus I group, alkyl group is a plus I group. Therefore aromatic carboxylic acids are more acidic than aliphatic carboxylic acid. Next point. But there is one exception in formic acid and benzoic acid. So which is more acidic? So we have studied that formic acid is more acidic than benzoic acid, even though formic acid is aliphatic carboxylic acid. Okay, so this is we have studied. Now let us see acidic strength of carboxylic acid is directly proportional to minus M effect, inversely proportional to plus M effect. Yes or no? Right, with respect to mesomeric effect. Therefore acidic strength of carboxylic acid is directly proportional to minus M effect. That means minus M groups increases the acidic strength of aromatic carboxylic acid. Okay, then let us see example. Tell me, let us take benzoic acid and orthonitrobenzoic acid. Next, benzoic acid, orthomethyl, no, I'll take one second. This paramethyl benzoic acid. Tell me, which is more acidic? First one, orthonitro. Why? This nitro group is a minus I minus M. You have to identify. If the group is present on benzene ring, it is a which group? That's first, no, very very important. Next is here, which group it is? Plus I hyperconjugation, right? Now which is more acidic? Benzoic acid. Okay, next one more example. Now let us take benzoic acid comma orthonitrobenzoic acid, metanitrobenzoic acid, paranitrobenzoic acid. So what is the order of acidic strength? It's nothing but Ka. It is A, B, C, D. Tell me, what is the order of acidic strength of these? So see, first of all you try to identify groups. It is a minus I minus M. This is minus M. This is no, only minus I. It is minus I minus M. Okay. Then where the electron withdrawing is more? In case of B, because minus I minus M will be same here, but minus I will be more because minus I depends on distance. So therefore here electron withdrawing is more, that means B is more acidic. Next is D is more acidic. Next is C is more acidic. Next is A. And see here in this order, orthonitrobenzoic acid is more acidic. Not only even because of minus I minus M, there is a one more effect called ortho effect. In case of aromatic carboxylic acid, there is a ortho effect. What is ortho effect? Ortho substituted carboxylic acid means benzoic acid is more acidic compared to benzoic acid irrespective nature of the substituent is called ortho effect. What is ortho effect? It means on ortho position, if any group is there, it may be electron releasing, electron withdrawing, yavudane irli. If any group is present ortho position, either here, so then acidic strength of that carboxylic acid increases nearly 1000 times. Then you can imagine, right? It is irrespective nature of the substituent. If ortho group present at ortho position, its acidic strength is increases. Therefore ortho effect. Ortho substituted benzoic acid more acidic than benzoic acid irrespective nature of substituent, right? So ortho substituted benzoic acid is more acidic than benzoic acid irrespective nature of substituent. It means, suppose let us take it is a benzoic acid and another benzoic acid having some X group on ortho position. This X may be what? Electron withdrawing group, or it may be electron even releasing group also. If any group, let it be electron withdrawing or releasing, any group present on ortho position, then orthobenzoic acid itself is a more acidic. Okay, for example, tell me, now let us take benzoic acid and another one is orthonitrobenzoic acid. Next, one more example, benzoic acid and here orthomethyl benzoic acid. Tell me, which is more acidic? First one. So yeah, what are the effect here? We know it is a minus I minus M. Along with these two, there is a ortho effect also there. Due to ortho effect, acidic strength is increases much more compared to other effects. See, if there is a ortho effect, you can neglect all the effects. Next, therefore, this is more acidic. Here, which effects are there? There is a plus I effect. Next, hyperconjugation and ortho effect. So remember, ortho effect is much more greater than plus I and hyperconjugation. Right? Therefore, which is more acidic? Orthomethyl only more acidic. Okay. Next. Now let us take benzoic acid. Right, ortho position having methyl group, ortho position having meta position having methyl group, para position having methyl group. Tell me, what is the order of acidic strength? Now I want a pKa. So tell me, yeah, which of the following has highest pKa, lowest Ka, or least acidic? Tell me. This is plus I, comma, hyperconjugation, comma, ortho effect. Therefore, due to ortho effect, it is become more acidic. More acidic, least pKa. So therefore, B is least pKa. Next is, this is, tell me, plus I, no hyperconjugation. This is plus I, hyperconjugation. Now, where the electron releasing is more? Electron releasing is D is more. It is least acidic. Then this. Then which is more acidic? Comparatively, now all this is more. But here, due to ortho effect, this is more. So therefore, B greater than A greater than C na D na? C greater than D. So therefore, D has highest pKa, means Ashtane, least Ka. Then what is the order of Ka, acidic strength? D greater than, which greater? B greater than, A greater than, C greater than, okay. That is increasing, this is decreasing order. Next, one more. So tell me, what is the order of acidic strength? So there are 3 NO2, 3 electron withdrawing group, more acidic, 2 electron withdrawing group, then 1 electron withdrawing group, no electron withdrawing group. It means as the number of electron withdrawing group increases, acidic strength is increases. Right? Similarly, right, so in exam, question will be like this. For benzoic acid, can be written form like this: C6H5CO2H. Okay, next, this one, it is NO2 written here, that is a ONO2, ONO2 C6H4CO2H. Yes or no? So what is the meaning of ONO2? Ortho NO2 C6H4 only. Why H4? 1, 2, 3, 4. Because there is no 2 hydrogen. C6H4. It is a CO2H. Next. Now here. Ortho NO2 comma PNO2. So C6H3 CO2H. Next ONO2 comma PNO2 comma again ONO2, then C6H2 CO2H. Okay, one more question. C6H5 CO2H A, C6H4 CO2H B, C6 Ortho NO2 C6H4 CO2H C, and PNO2 C6H4 CO2H D. Tell me, what is the order of acidic strength? Which is greater? So why C is greater? Ortho NO2. So if there is a ortho position substituent, ortho effect, ortho NO2 and ortho CH3 both are more acidic. So first comes ortho NO2. Why? There is ortho effect as well as minus I minus M will be there. Here ortho effect plus I hyper conjugation will be there. So therefore C is more acidic. Then next is B is more acidic. Next is D is more acidic. Next is A. So option should be given like this, or else this kind of option also be given. Next, relative acidic strength of phenol. Relative acidic strength of phenol. Tell me, acidic strength of phenol directly proportional to minus M effect, inversely proportional to plus M effect. That is as usual. But here one important note, in phenol there is no ortho effect. Okay, phenol do not exhibit ortho effect. So remember, in our syllabus we have aromatic carboxylic acid, benzoic acid and aniline and sulfonic acid. Benzoic acid, sulfonic acid, aniline, only these three compounds we have ortho effect. For other compounds there is no ortho effect because they are bulky group. For example, in case of COH, this is a bulky group now we have studied. Due to bulky nature, what happen? This carboxylic group goes out of the ring. If it goes out of the ring, there is no resonance between these two. Resonance will be, seized or not? The shifting of electron will be seized. So that means there is no resonance in between carboxylic group and benzene. The same kind is possible even sulfonic acid also. Okay, but if there is a methyl group here, if there is a methyl group or something X group, then it never comes to on the plane. Suppose if there is no any group here, there may be a possibility to come on the plane. But if there is a N something group is present, due to repulsion between these two, it is in one plane, this is another plane. permanently. It goes permanently another plane. So that is the reason ortho effect is possible here, right? Similarly, in case of phenol, what is the phenol? Phenol has like smaller group OH. Okay, even here something X group is there, then this OH and X do not goes out of the plane. It will be on the plane. So therefore, tell me, phenol do not exhibit ortho effect. So there is no ortho effect for phenol. But remember where ortho effect is possible. One, aromatic carboxylic acid, that is benzoic acid, sulfonic acid, benzene sulfonic acid and aniline, only 3 compounds. Okay. So therefore, now tell me example. Let us take phenol, same kind of example I will give here. Phenol and orthomethyl phenol, comma, metamethyl phenol, comma, paramethyl phenol. Come on, tell me. Phenol, orthomethyl, metamethyl, paramethyl. Come on, tell me, what is the order of Ka? Acidic strength. So again, remember, first identify what are the effect. It is a plus I hyperconjugation. Only plus I hyperconjugation. So hyperconjugation will be same in 1 and 4. Okay, then tell me which is more acidic. Ortho effect is not there. If there is a ortho effect, you could say it is 2. Therefore here first one is more acidic. Next is third one is more acidic. Why? When methyl group present at meta position, the electron releasing effect is less because of only plus I group, plus I effect. Next is 2 and 4. 4 is more acidic. Next is 2 and more acidic. Tell me. So what is the order of acidic strength Ka? Which is more acidic? Second, because there is a minus I minus M here, minus I here, minus M. Therefore, second is more acidic, but not. This is one important question in board level. Board level exam alli one important question barutte. Heli. Why orthonitrophenol is less acidic than paranitrophenol? So paranitrophenol is more acidic. Even you have studied in chemical bonding also. Hydrogen bond. So because of hydrogen bond. See, in case of orthonitrophenol, actually it's supposed to be more acidic, but there is a hydrogen bonding present like this. There is a intramolecular hydrogen bonding. Due to intramolecular hydrogen bonding, this hydrogen never come out easily as a H plus. It means it does not undergo dissociation because there is a conjugation. There is what is saying? It is chelation, the formation of cyclic ring. A cyclic chelation will be formed. That's what this H is there, but it cannot be come out as a H plus. It is not easily dissociate. Therefore, when compared to 2, 3 can dissociate easily. The 4 can dissociate. So therefore, what is the order of Ka? 4 is more acidic than 2. Then 2 only. Next 3, then 1. So therefore, this is exception important. So why para-nitrophenol is more acidic than ortho-nitrophenol? It is due to intramolecular hydrogen bonding. Due to intramolecular hydrogen bonding, its property, many property changes: melting point, boiling point, solubility, viscosity, volatility, etc. You have studied in chemical bonding. Okay, it is nitro group. When suppose as the number of nitro group increases, what happens the acidic strength? Okay, it is a ortho-nitrophenol, ortho comma para dinitrophenol, ortho para and ortho. Tell me, which is more acidic? So there are 3 NO2 group, 3 electron withdrawing group, which is much more acidic compared to 2 and 1. So therefore trinitrophenol is most acidic. Do you know its acidic strength is almost equal to sulfuric acid. Okay, you might have done experiment with sulfuric acid. So once, okay, if you place your hand in constant sulfuric acid, you should forget about your hand. Only skeleton matra rehta. Like that, trinitrophenol also, it has almost pK value, similar to this sulfuric acid. It means it has more, almost equal acidic strength compared to sulfuric acid. So you can imagine, even though organic acid, usually organic acids are weak acids. Even though it is organic acid, that too phenol acid, right? It is a more and more acidic because of 3 nitro group, and it has commercial name also. Anybody? What? Picric acid. Trinitrophenol. 2,4,6 trinitrophenol is called picric acid. It's given once in a board exam. Okay. Next, similarly, as the plus I group increases, it means electron releasing group increases, what happened? Orthomethyl, ortho comma para dimethyl, tell me which is more acidic? There is no ortho effect here, right? So this is the decreasing order of acidic strength of phenol. Okay, in phenol now they make you question like this. It is a C6H4, it is orthomethyl C6H4 OH. Okay, it is ortho comma para C6H3 OH, orthomethyl comma paramethyl comma orthomethyl C6H2OH, like this. You should understand it. 1, 2. Okay, it is acidic strength of phenol. Next, last one is relative basic strength of amine. We'll continue next class.